Hi, Assalamualaikum. My name is Nobushra Nakibah binti Mansi. I'm from CS247-6B1. My matrix number is 2019-583-903.
Assalamualaikum. My name is Mardiah Auni binti Mahathir. My matric number is 2019 552029 from N4 CS247 6B1.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Syazwani binti Muhammad Yani from CS247 6B1 2019 33 8747.
Assalamualaikum. My name is Nurul Ashikin binti Mat Yaman. My matrix number is 2019 527 845 from class CS247 6B1.
And my name is Hazwani binti Mahyudin from N4CS2476P1. My matric number is 2019361675. We will present about multistage network including Omega network.
Before we go further with the multistage interconnection network, let me show you the difference between buses, crossbars, and the multistage. So buses is excellent in cost scalability but is poor in performance scalability, while crossbars is excellent in performance scalability but is poor in cost scalability. But multistage is something different, that it strike compromise between these two extremes, between buses and crossbars. So the reason why multistage is compromise between buses and crossbar is because in terms of performance, it is more scalable than the buses, but in terms of cost, it is more scalable than the crossbar. So the multistage is formed by cascading multiple single-stage switches. In order to form a completely interconnected network, the switches can use their own routing algorithm or they can be controlled by a centralized router. In multistage, there are three types of network, that is non-blocking, rearrangeable non-blocking, and blocking. For non-blocking network, it can connect any idle input to any idle output, for example like crossbar network. For rearrangeable non-blocking network, it can rearranging its existing connection by establish all possible connection between input and output. For blocking network, it cannot realize all possible connection between input and output. It is because of a connection between one free input to one free output is blocked by an existing connection in the network.
So we will learn about the multistage interconnection network applied in parallel computing. So the diagram above will show you a schematic of typical multistage interconnection network. There are processor, several stages, and memory bank. Okay, we will learn how to apply formula in this Omega network. This network consists of log P stages where P is the number of input or output. At the stage input I is connected to output J. We will look into the first formula, 2I, when the condition I more than equal to 0 and I less than equal to P over 2 minus 1. For the example, if the input I is 0, so it will connected to output 0. So we will look into second formula, 2I plus 1 minus P, when the condition is I more than equal to P over 2 and I less than equal to P minus 1. For the example, the input is 5, so it will connected to output 3. So the diagram above will show you a perfect shuffle interconnection for A, input and output. So the first one is 0, it will connected to output 0. If the input 5, it will connected to input 3. Is the mode in switch operation. There are two modes in switch operation. The first one is pass-through. The second one is crossover. A will show you the operation mode is pass-through. B, it will show you the operation mode is crossover. In the diagram above, we show you a complete omega network connecting 8 input and 8 output. An omega network consists of multiple stages, 2 by 2 switching elements. Each input has a dedicated connection to an output. And n by n omega network has log n number of stages and n over 2 number of switching elements in each stage for perfect shuffle between stages. Thus, number has complexity of n of 0 and log n. Each switching can employ its own switching algorithm. So, we will look into the diagram above. It will show you 8 by 8 omega network consists of 3 stages, with each stage consists of perfect shuffle followed by 4 switches. So I will pass to Nurul Ashikin to explain more how multi-stage interconnection network apply in parallel computing.
We are going to show you how it's worked by using 8 times 8 omega network. In this example, we will use 2 times 2 switch. The formula is n equals to log 2p. Since the number of output and in the input is 8, so the number of stages is 3. There are 2 ways to determine the output, which are by using formula and rotate left method. The omega network will use the formula to determine the output for the specific value of input I. Note that this is the value of binary codes. This value can be applied into the formula to get the value of the output. These are the output for 8 times 8 omega network. Since there are 3 stages, we have to repeat the process for 3 times. Instead of using the formula, the output can be determined by using rotate left method. By using the binary code, the output can be gained by rotating the code to the left. For example, at value 4, 100 will give output 001, then 010, and back to 100. So this is the complete outputs for 8 times 8 omega network by using rotate left method. This is schematic of 8 times 8 omega network by using 8 outputs and 8 inputs. There are 3 stages, stage 1, stage 2, and stage 3. Okay, we will show you how to connect the input to the output by using 2 inputs. We take 0 as the input. First, it will connect to 0. At this stage, the first binary code of 0 is 0, so it will connect to 0. At this state, we will use 0 as the input, so it will connect to 0. Hence, we can reuse the result for the next steps. Okay, for the next example, we take 1 as the input. Firstly, 1 will connect to 2. At this stage, the first binary code for 1 is 0, so it will connect to 0. We take 2 as the input. Then, it will connect to 4. And then, at this stage, the second binary code for 1 is 0, so it will connect to 0. We take 4 as the input. It will connect to 1. At stage 3, the last binary code for 1 is 1, so it will connect to 1. And then it will direct it to the output 1. So this is the complete interconnection for 8 times 8 omega network. There is self-routing property in routing in omega network. This happens when significance bits of destination is more than the source. This will come out as the unique route between the source and destination. Note that this is not a non-docking switch. We will show you how the self-routing works. For example, the route from source 110 to destination 011. We can write the binary code of the output below the stage as the reference. Take 110 or the value of 6 as the input. First, this input will connect to 110. At this stage, the first binary code of 011 is 0, hence the crossover switch will be used. It will connect to 0 at this switch and the value of 4. Then it will connect to 001 At this stage, the second number of binary code 011 is 1, so it will connect to 1. Then it will connect to 010. At this stage, the third binary number for 011 is 1. Hence, the crossover switch will be used. Then it will connect to the output of 011.
Next, this is an example of blocking in Omega network. One of the two messages, which are 010 to 111 and 110 to 100, is blocked at link AB. This happened because the message used the same path. So now I will explain about the advantages of multi-stage network, including Omega network. The first advantage is multi-stage performance is more scalable in terms of performance if we compare to the bus network. The second one is Omega network is the ease of routing. This is because the routing is completely distributed. The third one is if we compare in terms of cost, it is more scalable compared to crossbar network. The last one is the number of paths of connection can be more. Now I will explain to you what is the disadvantages of multi-stage networking, and this also include the drawbacks of Omega networking. So the first one is the lack of proximity, and the second one is the fixed distance between any two nodes. This is because all the nodes are at the same distance from any other node. And lastly, multi-stage network can cause blocking. So there are some disadvantages of multi-stage network.
Next is current issues in multi-stage network. One of the issues is link conflict. The problem of link conflict can arise due to traffic load on a single link. When two or more packets from different sources request the same link or wavelength in a switch simultaneously, the congestion occurs at that requested output link, and this leads to link conflict. If some or all the source accesses their destination addresses in a same time slot, then there may occur the problem of link conflict in the Omega network. This figure is 8 times 8 Omega network with link conflicts. The problem of link conflict in the Omega network is represented by dotted lines, while the conflicted routes are represented by arrow. In this figure, the link conflicts occurs when signals trying to access the same path at the same time slot within the switching element. Practically, this activity is not possible. Next issue is exploiting Omega networks to hide text in text messages. Allah Hamarsheh in 2015 introduced a new steganography mechanism which can be used to hide text in text messages using the Omega network. Steganography is an effective technique to secure data transmission over the internet. This paper proposes a new method called modified Omega network for hiding and extracting the text message from another text message. Using the structure of Omega networks, the researcher generates two processes, which is embedding process and extracting process. This figure is part of Omega network with 5 stages to embed the characters. It is used to hide the secret messages by generating new words based on characters of the original message. And this figure is part of Omega network to extract the characters. It is used to retrieve the secret message from a stego message that was generated at the sender's side. There are 9 references to come out these presentations. The details of the references lead us to be more understanding about the multi-stage interconnection network. We take this opportunity to say thank you to Madam Saliza Ramli for guiding us in making this short video for education.
Thank you.
Thank you.